Welcome back. We're almost done. Don't be overwhelmed yet. This is basically referring to Section B of the task list experimental design. As you go through the courses in each of your different chapters and different sections, you're going to run into a number of questions about function. Since behavior is a function of the environment, the way we identify function is to identify the behavior, get some data on it, and then manipulate some variables to see if we can make it go up or go down. The question is, can we even change the behavior? If it at least changes, we know it's available due to some environmental factors to be changed. If it's going up, we want to go up, and we know something reinforced it. We have to figure out what's reinforcing it and not reinforce that behavior, or reinforce something else that's better than that problem behavior. So this is a quick overview of experimental design. In the top left is the scientific method as an ongoing process. I won't run through all the steps. My goal here is to get you to take a quick look and realize we know a tremendous amount about the science of behavior. We know a tremendous amount about the lawful relationships. Experimental design for behavior analysts is what we call single subject, rather than a large group design with random assignment. A control group where you measure the behavior before treatment and then after treatment, and then use statistics to see if there's a probability that that would have changed. That's a common statistical model. Statistics is an incredible tool for identifying large groups to see if a particular treatment had an effect. For example, birth control on a large number could see, does this particular pill have an effect on the rate of birth? With behavior analysis, we're often looking at clinical significance, and often even more so at social significance. So instead of having the variability of behavior taken out in statistics, we take out variability for each individual subject. So we call it single subject. We get repeated measures of the same person's behavior again and again and again to look for that pattern. So what you're going to see is, basically, you're going to need to learn about looking at the data and interpreting that. So you're going to learn about level, trend, and variability. Then you're going to learn about baseline logic, where we talk about the prediction, verification, and replication. Again, with science, we have description, prediction, and control. We're going to manipulate variables. Those are independent variables. We're going to then measure the behavior. How someone behaves depends on how they're treated. So the treatment model is the independent variable, and the dependent variable is how the person behaves. You're going to learn the terms and concepts for experimental control, where you manipulate the treatment, the independent variable. You measure behavior changes, the dependent variable. You're going to look for the functional relationships to see the behavior changed when and only when you did the treatment. We have to interpret the data as far as its level, trend, or availability. We do a visual analysis, some call it eyeball analysis. It has to be practical. It has to make sense. We're going to look at different designs. Different designs have strengths, they have weaknesses. You're going to learn about internal and external validity for the subjects, within and between subjects. So in a nutshell, here are basically a dozen graphs to show first level, trend, variability. And you'll start to be able to look at those and quickly see, is it trending up, is it trending down, is it stable, is it variable? The next one is going to show an example of what we call an ABAB design. It doesn't show us, it shows us that we had the baseline and then we had a treatment. Did it change during treatment? The prediction is that it wouldn't. If it did change, then we go back to the point of taking out the treatment to verify that it changed when and only when the treatment was in place, and that's our verification. Prediction is it wouldn't change. The verification is that it did. Then if our treatment was successful, we put our treatment back in, and now we do replication. We went from predicting it wouldn't change to verifying it did change, and then replicating through repeated demonstrations that what we are doing to the environment is actually having an effect on this behavior. They typically start with an A-B design, which is simply a baseline and then a treatment. The advantage is it shows us if it changed. The disadvantage is it doesn't let us argue that it's a functional relationship because it may have changed for some reason we don't know. The next design over is an ABAB, sometimes called return to baseline, sometimes called withdrawal, sometimes called reversal. They're very similar, but there's a slight difference, and you want to be sure to learn the difference between return to baseline, withdrawal, and reversal. What you see is a low-level baseline, then the behavior goes up during treatment. It goes back down during baseline when the absence of treatment. It goes back up with treatment. This lets us better argue that in the presence of treatment, there's a higher rate of responding, therefore a functional relationship between behavior. We see the lawfulness of the environmental stimuli used during treatment, producing a change in responses. We take out that treatment, we see the behavior go back to a different level. This helps us make a good argument that we have identified the functional variables that make behavior go up or go down. The next line is a way to use this, another way to show the treatment effect without pulling out the treatment. So there are advantages of a multiple baseline as opposed to the other. We just saw the ABA design, when you have to stop treatment to show a function. There's a solution to that is the multiple baseline. You need to read about and learn that to see that you start treatment delayed for the second or third behavior, or the second or third person, or the second or third setting. It has more than one baseline, and it lets us take advantage of prediction, verification, and replication to show and make our case that there is a functional relationship, that it changes when and only when we do our treatment. Multiple probe design is next, which the advantage of that is it saves us collecting a lot of data. It still lets us make our case. There are also multi-element designs, which means we have more than one independent variable, and that's referred to as an alternating treatments design. We do one treatment, and then we switch rapidly to a different treatment, and we go back and forth, maybe an hour of this, an hour of that, maybe a day of this treatment, then a day of the next treatment. If we see a distinction between the two lines, we know that there was a functional relationship that in this case, the treatment on top, treatment A, produces a higher level of responding. Treatment B produces a lower level responding. Is treatment A better? Well, that's a socially significant question, because if you want more behavior, treatment A produces more behavior. If you wanted less behavior, then you pick treatment 2. The science and the data just tells us what's happening. The value judgments then are when we apply it to socially significant behaviors. As experimental psychologists, as experimental behavior analysts, we want to see, can we in fact change the behavior for the better for the client? Then the people that consume the results of that training are consumers, teachers, society, parents, family. That's where they have to decide what they value, and that's where the cultural influences come into our behavior. The next graph is a matter of taking an independent variable and gradually increasing a little bit more at a time. So you'll see another design where we're going to gradually increase. It's called changing criteria. We gradually raise the amount of responses, or the duration of the response, or the intensity. The bottom line is another multi-element design that has a component, a number of different procedures involved. We know how to systematically test and compare one conditioner to the other, how to check that on each side of the treatment we have a difference to show a functional relationship. It's important to learn about and understand and study all of these designs. The next one over is called parametric measures. I won't have time to go into all of these now, but in your chapters and your discussions and the articles you're reading, you'll be able to see tons of experimental designs. Your challenge as the behavior analyst is to learn these and know these. Someone told me once, they said, I just need to learn enough to pass the exam. And I had to tell them that won't work. It's not about just passing the exam. You really need to learn the science of behavior to be a better practitioner, to pass the exam for certainly, but to be the best practitioner you can be, you've got to learn the science behind it. There is no shortcut. You basically need to leave a program with the equivalent of a master's degree in behavior analysis. You just can't not know some pieces of it. When you're doing ABA, you can't not do all 7 pieces. Otherwise, you're not doing ABA. You're doing SLI, something like it. So the board, BACB, is dedicated to us using ABA. We get certified for ABA, and if you're a behavior analyst, be an ethical professional, you will learn the science of behavior, and you use the 7 dimensions. If you're not using them, you're simply not doing ABA.